Hello everyone. I wanted to show the Spherical Voxel planet game that I've been working on. Um, so right now the camera is on the surface of the planet, and as you can see, everything's made out of Minecraft blocks that you can destroy and you can build. So for example, this is water. Physics is disabled right now, but as you can see, you can sort of fly around the planet. I have a sort of a low level of detail mesh for the surface of the planet, and then as you fly around, the blocks sort of load in. Right now lighting is disabled, but you can see the sun is sort of going around us in a circle, which means that we're actually on the north or south pole right now. So like I said, this is actually a planet that's made out of voxels. So what you can do is you can fly up and you can leave the surface of the planet. So for clarity, I had lighting disabled on the surface, but you can see this is the view of the planet from space. See the sun's over there. And what you can do now is you can go anywhere and you can land anywhere you want. So for example, I can land right here. As we fly down, the blocks are going to load in. However, there's one very big issue with making a sphere that is tiled with voxels, and that's the problem that you cannot actually tile a sphere with a grid of squares. There are many projections that allow you to project squares onto a sphere, but essentially all of these projections have two issues. The first issue is the distortion, and the second issue is the fact that at some points on the sphere, the grid that you're projecting will meet up with itself, but not actually line up with itself. So for example, probably one of the simpler projections is the equirectangular projection, which maps latitude and longitude on the sphere to x and y coordinates on a flat map. So as you can see, sort of near the equator, the blocks would actually look cubic, but as you move up away from the equator towards one of the poles, the blocks would end up looking like more and more rectangular, so they're going to become more and more distorted. And then to illustrate the second problem, as you move up towards the pole, all of these blocks are going to essentially, they're all going to touch at the poles, but they're not going to meet up in a grid. However, there is one thing you can do to try and avoid the distortion, and that's instead of taking this grid of squares and then projecting it onto a sphere and rendering the projected blocks, what you can do is you can just take this flat plane of blocks and render it as if it was a flat plane, and then if you really wanted to, you could use a vertex shader to fake a curvature on blocks that are way far away from the camera. So that's going to eliminate the distortion when you're on the surface of the planet. However, it's not actually going to eliminate the distortion completely. It's simply going to ignore the distortion up until the point where you transition from the surface into space. And not only that, but it will not actually fix the issue with the poles, which is that these all these blocks that are on the north and on the south pole, they do not actually line up in a meaningful way that you can actually represent in a voxel game. So I want to go over some of the methods that I'm trying to use to present this voxel planet to the user in a way that does not look broken, and try to eliminate some of the distortion, some of the problems that are arising. So to begin, when you're on the surface of the planet, you're actually walking along the surface of a cube. So you can think of this as taking a paper cube and essentially unfolding it. So a cube has 6 faces, and each face is a square, so it's very easy to then take this square, to take the face and then subdivide it into squares and blocks and whatnot. And what I've done here is I've drawn how each face connects to the faces around it. So as you can see, for example, if you start on this face and then you walk north, you're going to pass over the North Pole, and then you're going to come down on the other side of the planet, and you're going to be walking to south, and then you're going to walk over the South Pole, and then you're going to come up and you're going to end up where you started. Similarly, if you go west, you're going to wrap around and also come back where you started. Now it's very easy to just take this cube and then project it onto a sphere just by sort of bulging out the sides and just normalizing every single point on the cube. But as I've said before, when you're doing the projection, there's going to be distortion. So you can see this in effect here. So right now this is in surface mode. So you can see the surface, and then as you fly up past a certain altitude, the world just bends into a sphere. And as you can see, not only is some of the stuff on the horizon, bending downwards when it becomes a sphere, but also surface features that are close to the camera slightly change shape because of the distortion. After the world has been bent into a sphere, you can then fly up and then fly to a different place on the world, and then as you fly downwards, the same thing will happen in reverse. However, there's one big thing which I've so far not shown, and that's the fact that when you're on the surface of the flat unfolded 2D cube, once again, there's no issue going between faces over the edge, but if you go towards the corner, there's going to be a very big issue, because essentially, like if you're standing here, there's a face behind you, there's a face to your north, there's a face to your west, but essentially there's this very big empty gap where there are going to be essentially no blocks. And what's more is, once you take this flat cube and you fold it down, the top of this face is going to be touching the left side of this face, but of course when you unfold it, there's this big empty gap here. And so as you can see, when we go towards the corner, there's this gap. And furthermore, if you're standing here, the face number 3 is to your left, right? But as you walk across onto face number 4, the face number 3 is still going to be to your left. It's just going to be from a different angle. So you're now, so if you're standing right here, you're looking at it from the left. But if you're standing right here, you're going to be looking at it from the top, if that makes sense. So to demonstrate, for example, if you can see there's a little gulf or like a bay right there, as I walk across from one face to the other face, we're looking at the same face over here, it's just we're looking at it from a different angle. So once again, you can see like the same gulf out there in the distance. It's just, instead of it being in that direction, it's now in this direction. And this is actually a very big problem. Ben Arnold, the creator of Seas of Andromeda, had this very same problem, and essentially his solution was to make it so that the player could not actually travel to the corner or just something along those lines. However, someone on Discord presented me with what I feel is a much better solution that I've actually implemented. To sort of understand this solution, which I've implemented, I want to sort of visualize it or illustrate it. So as I've talked before, the left side of face number 4 is actually touching the top of face number 3. So what I'm going to do is I'm just going to draw face number 4 like this because it's, these two edges are actually touching. Then I'm going to take face number 3, and since the top of face number 3 is touching the left side of face number 4, I am also going to draw it like this. So what you can see is we can essentially fill in this empty space with the blocks that we already have. So here's a screenshot of the original Discord post, and you can see how, like, if we're standing right here on the red face, the yellow and the blue face are actually touching, and you can see the blue face is touching the yellow face on the left, and the yellow face is touching the blue face on the right. So this is just, like, once again, just a visualization of it. But as you can see, what he's suggesting is to divide this space along with a line, and then everything to the left of this line will be the face that's actually on your right, and everything to the right of the face, or everything to the right of the line, is going to be the face that's to your left. So that is exactly what I have done, and you can see that the empty face, I can take it and I can fill it in. So you can see the gulf is over there, and you can see it at the same time it's over there. And what's really good about this method is that as you go around the corner, there's a sort of seamless transition, so nothing jumps out at you. So for example, if we just leave it as blank, when we go across these, the face like jumps from being over here to being over there. But with this method, we can sort of go around the corner and nothing really jumps out. What's also really good with this method is that if you see something, you can walk towards it in a straight line and you'll get there. So for example, if I walk here, I can arrive at this point, and if I walk over here, I can also arrive at the same point. And then I can walk back, and I'm back where I started. The actual implementation is quite simple. It's literally just taking all the meshes of the chunks in the far terrain on the left and all the meshes on the right, and it's just rendering them in the empty space at different angles, and it's using a GL clip plane in order to subdivide the space to make it so that the two don't actually overlap. And the clip plane follows the camera around, and as you sort of go to the left, you can see that the blocks that were over there, you can see them right there, and then as you keep going left, you can now see the structure that's over here, you can see it over there. You keep going left, you can see the structure that's over there is now over there, and so on. So that's basically what I mean when I say it's basically seamless. So as you go around it, there's nothing really jumps. There's however, one big problem right now, and that's the fact that in order to render objects that are in space, the direction you're looking on the surface and project it into like three-dimensional space. And because of the distortion issues, when you move across two different faces, it causes the sort of angle to jump, and this causes objects that are in space to jump, as you can see right here. With the cube sphere projection, the distortion is actually the greatest at the corners of the cube. So you can see how when you transition from the surface into space, everything shifts by a very big amount. You can also see that when you complete the transition, everything that's in this empty space has to essentially disappear in order so that the left and the right face can join together, and you can see that that transition is not very clean right now. So those are some of the issues that I've been trying to solve, but other than that, it's everything just sort of works right now. um, but it doesn't work very well